Hello, my friends. I'm Clover. This is Genuinely Approachable Sudoku, and today we're going to be solving Irresponsible Miso by Philip Newman. So this is a Thermo Sudoku. So we have standard Sudoku rules, replacing the digits 1 through 9 once each in each row, each column, and each outlined 3x3 region. And in addition, we have some thermometers in the grid. And on thermometers, the digits have to increase, starting with the lowest digit at the round bulb end and increasing towards the tip. They don't necessarily have to be consecutive. So for example, that could be 1, 3, 4, 6, 7, 9, something like that. So all of these thermometers are the same length. And in fact, Sudoku Pad has this clever little tool where if you double click on a particular position on a thermometer, it highlights the same position on all thermometers of the same length in the puzzle. And so we have a trick for determining how many degrees of freedom the digits along the thermometer has, which is to take the length of the thermometer, in this case it's 6, and subtract it from 10, and that gives you 4 degrees of freedom. So we're going to mark that as 1, 2, 3, 4, because there are 4 options. That's going to be 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8, 6, 7, 8, 9. And this feels like a little bit of a cheaty way to approach thermos. This is genuinely something I do quite often when I'm solving thermometer Sudoku on just the Sudoku Pad web app. So no shame in doing it whatsoever. I think it's a good way to kind of visualize what's going on in a puzzle. So this can't be a 9. So because the digits have to be increasing, we can eliminate the highest digit in each of these other positions. That can't be a 4. That also can't be a 4, and therefore that can't be a 3. And I think that's all the cleanup I can do here right now. Can I do any cleanup here? So this can't be a 3 or a 4 because there's a 3 and a 4 in the region. So we can eliminate the 2 lowest digits from each of these. That also can't be a 3 because it sees a 3 here. We can't have a 6 or a 7 here, so we can eliminate them there. So we get to eliminate 5 and 6 there, 4 and 5 here, 3 and 4 here. And this also can't be a 6. Okay, so the question now is, where do we go next? That can't be a 6 either. Let's see. And this is, for me, a blind solve. I have not solved this puzzle before, so I'm going into this as if I'm seeing it fresh for the very first time. So a couple things stand out to me. One is that I have 2 digits here that are already quite low. This one is 1 or 2, this one is 2 or 3. And I can only put 1 more digit in this column that's from the range 1, 2, and 3. So therefore, this can't be 2, for example. Actually, I know a little bit more than that. So there's a 1 in that region, so I can eliminate the lowest digit here. Now that means this can't be a 3, because if that's a 3, then this is a 2, and then we have a problem here where we can't put anything into that cell. So that's not a 3, we can eliminate 4 there, and that makes this definitely a 7, which resolves the end of this thermometer. So that's our first kind of resolution here. So this can no longer be 8 or 9. That can't be an 8, and now that can't be a 7 because we wouldn't be able to have these be increasing along the end of the thermometer. Now that makes that a 5. So we go 4, 3, 2, 1 and eliminate a 2 from right there. So now this can't be a 2 or a 5 since we've placed those in the row. So that's going to be a 4. And this is not going to be a 4. So we have 1, 2, 3, 4 in this column. Now that's kind of interesting because that means we only need to place high digits here. So we may get to do something like that with that in a second. That's going to be either 7 or 8 in the row. Yeah, so let's mark these as 5, 6, 7, 8, 9. So this sees a 6, an 8, and a 9. So I'm going to eliminate 6, 8, 9 here. That can't be a 5 since there's a 5 in the region. That's not an 8 and that's not a 7. And these are not 5s. In this region, I've got 5, 8, and 9. And I can eliminate an 8 from here. These can be 2, 3, 5, and 9. That's not a 3 because there's a 3 in the row. That's not a 9 because there's a 9 in the row. And I think that's not exactly the right place to look yet. So let's keep looking. I have a 7 in this row. And therefore, that's not a 6, that's not a 5. So that goes 3, 2, 1. And I have a 4 right here, so that's now a 5 with a 6, and this is going to be a 6. And my last digit in this row has to be a 3. That's the only digit remaining. And so now to finish this region, I need 4, 5, 6, and 7. There's not a 5 there. There's not a 6 there because there's a 6 in the row. So that's going to be a 6. And I have 4, 5, 7 right across here. The 5 needs to go right there. And therefore, this is not a 5. I have a 5 in one of these two cells. These guys are going to be 1, 2, 4, 8, and 9. And these can't be 4 or 9 because those are already in the region. Actually, not 1, 2, 4, 8, 9. 1, 2, 8, and 9. And that can't be a 1. That gives me a little bit of additional information. This can't be a 5 because there's a 5 right there in the region already. I have a 1 and 2 here, so this is now going to be a 3. And that's not going to be a 3. I have a 5 there in the column, so that's not going to be a 5, so one of those is a 5. And I have 7, 8 as a pair here. That makes this a 9 since it can no longer be an 8. And that can't be a 9. And so this column needs a 1, 2, and 5, and that can't be 2 or 5, so that's my 1. And therefore, 1 in this row has to go into one of those cells. This can't be a 6 because there is a 6 in the row. And here I have a 2 or a 5. Okay, that makes sense. Here I can eliminate a 2. Let's see. I need an 8 in this column. It can't go in those cells because there's an 8 right here. Therefore, that is my 8, and that's a 5, 9 pair. And I can eliminate 9 from here and 8 from here. And here I'm going to need 3, 4, and 9. And one of those is definitely going to be a 9. I need a 1 in one of those cells. And I'm not sure exactly what else I'm going to need here. So we'll leave that for the time being. In this column, I need 2, 4, 5, 8, and 9. That's not a 5. Those are not 8s. That's not 2 or 5 or a 9 because there's a 9 in the region already. So that's going to be a 4. And now that that's a 3, 9 pair, I know that this has to be a 4. That cannot be a 9 because there is a 9 in the row. That can't be a 9, so this is going to be a 2, 5 pair. And to finish off this row, I need 4, 6, 7, and 8. That's not a 6. So interestingly, I get this 4, 7, 8 triple here. So I still need 1, 2, and 9 to finish off the column. And that cannot be a 1 or a 9 because I know 1 is in one of those cells, so it's not here. And I know 9 is in the 5, 9 pair in the row. So that's going to be a 2. And that tells me that the only position for 2 in this region is right here, which resolves the 2, 5 pair. And from there, where are we going? So we can eliminate 4 from there. That makes this cell a 4 in the row. And this is going to be 6, 7, or 8. So now we now have a 6, 7, 8 triple here. And that means the remaining cells in the column are 1, 2, and 5. That's not a 2. That's not a 1. I can eliminate an 8 from here. And therefore I have a 6, 7 pair that places an 8 right here. So I can eliminate an 8 from here as well. There's a 3 in the row, so that's going to be my 9, which will make this an 8. This is now going to be a 1, 2 pair. That's going to be 6, 7, and 9. The 4 I placed a moment ago gives me a 7 here and a 4 here, which resolves this 7, 8. And that is going to give us a whole lot we can do via classic Sudoku techniques. So I'm just following through and resolving my pencil marks. And at this point, it should just be a matter of following up on the classic Sudoku. Last digit in this region is a 7. Last digit in this column is an 8. That's now going to be a 6. This is going to be a 3. Here I need a 1 or a 7. That can't be a 9, so that's a 1, a 2, and a 1. 9 and 7. 9, 6, and 7. And that is how you solve Philip Newman's lovely Irresponsible Miso, which I believe was named by committee at SudokuCon recently. Hope you enjoyed that one. It was a little bit of a tricky one for me, but I liked it nonetheless, and the visual theming was on point. If you want to solve it yourself, the link to check it out is in the description below this video. And I will see you again in a couple of days.